Good afternoon, everybody. The first edition of a digital Farnborough Air Show. I am Remo Gerber. I'm Chief Operating Officer for Lilium, and I welcome you to our brand new facilities where here in Wessling we're going to manufacture in the future the Lilium aircraft, the future serial manufacturing of our production. It's a great pleasure to be here, and today I want to talk to you a little bit about what we have done as Lilium in the last 5 years, but also, of course, what we're going to do towards our launch in 2025. Of course, to date we have shown a number of different aircraft demonstrators, starting with the two-seater aircraft that flew in 2017, the five-seater aircraft demonstrator that flew in 2019, and right now as a company we're very much focused on the certification, industrialization, and ultimately the go-to-market and go into service of the serial aircraft that will happen by 2025. Behind me is our brand new facilities. We have built to date about 30,000 square meters of manufacturing capable infrastructure, which of course over the coming years we will be kitting out with all of the manufacturing facilities and the machinery that is going to be needed for serial manufacturing. Our business vision is to connect entire regions. Many people hear today about urban air mobility and they're thinking about flying from one part of the city to the other. We do not, however, believe that this is where this whole industry is going to start. We very much believe, of course, to fly into cities and to connect city centers with other city centers. But the biggest goal that we set ourselves is to save time for our customers. And for that, you do need a certain minimum distance for a first mile and a last mile transfer to really make sense and to create that time gain. So there were three elements that we specifically focused on. One is the range of the aircraft, so we can connect cities as far away as possible and really create the time gain. Side effect of that is with range, it's much faster on shorter distances to recharge the batteries. Secondly is around the speed. So we can actually do that very effectively and actually really create the time gain from an inner city to another inner city. And last but not least is around noise. Creating an aircraft that is very, very quiet as possible, about 6 to 7 times quieter than a helicopter, so we can fit into existing city noise environments. And also, more specifically as well, use the sort of arteries that connect our cities, motorways, train lines, rivers, you name it, in order to create almost like the perfect combination for not bothering the people that live there and still connect them with an aerial service. As you just seen on the video, of course, the aircraft follows a very new type of concept, that of using ducted fans for a vector thrust architecture that is following a canard function with the two main wings and the two canards at the front. So why have we taken the approach of this type of architecture? It's for a number of different reasons. First of all, of course, we were looking for the optimal trade-off between the aerodynamics, the ability to take off and land, and of course having the optimal aerodynamics for fast and efficient forward flight in order to achieve the range. Right? And then you see that here, of course, by the whole concept of the aircraft, with including the body being part of the type of wing configuration, no tail in the back, and really like the engines and the flaps integrated into the aircraft. And what you're seeing also is the 36 engines distributed across the 4 wings with 12 flaps that are all ultimately creating the vector thrust for the aircraft steering. And also, of course, what's very important is the engines themselves, them being ducted. It creates quite a unique opportunity both on the safety side, because of course we will have to design against blade loss, against any sort of bird impacts, and through that we can, on the one hand, of course, safeguard the fuselage, but also of course the surrounding elements, but also we can ensure that we don't have cascading effects between the different engines. But also secondly, which is quite interesting and different to common opinion, of course, with the small ducted fans and with the small engine diameters, we can, on the other hand, use the ducted concept through liner technology, which in many cases is actually already very well understood technology. We can actually absorb the noise that we're creating within the engines. And through that combination, we can create a very beneficial trade-off between the safety concepts, the noise, and the efficiency. Having the aircraft, of course, is only part of the whole puzzle piece. And talking about entire regional air mobility is probably for many people still somewhat unknown, because we don't have it today, and probably the closest we know to regional high-speed transportation is trains. So how are we thinking about replicating that in the air? For one, we have to understand here is an opportunity to grow networks where we can connect many towns, cities, even small villages with 300 kilometers per hour, and that has never existed before. So think about it, we are right now, unfortunately not in Farnborough, but in spirit in Farnborough, but we could be back in central London in less than 15 minutes. And I think that is a bit the point of, like, we can connect a place like Farnborough, but we could also, of course, connect a place like Oxford or Birmingham. And when we look at the UK map, with actually 20 to 25 individual points in the 300 kilometer radius, we can connect the entire country with high-speed transportation, of course, as well including Wales, and then this network could even grow further up north. And to get a sort of a sense of what that means with 20 individual locations, assuming that they're about 70 kilometers apart each, and then connecting all of them, as you're all aviation people, you know you can fly anywhere in 360 degrees. But 20 connections, 20 ports create nearly 200 different routes that you can connect to. And with an average of 70 kilometers, we're talking about 10,000 kilometers in an entire region of high-speed transportation that could be built in a reasonably short amount of time. Of course, in some areas we would create new infrastructure. In other places, we could even use an airfield like Farnborough and service the neighboring communities. But putting 10,000 kilometers of high-speed transportation into context, that's about 3 times more than the entire French TGV system. What would that cost us? Maybe 200, 300 million pounds, if that. It depends a bit how much new infrastructure versus old infrastructure. But that is a fraction of the 100, if not potentially hundreds of billions it would take to ever do something similar, or actually doing a single line of 300 kilometer as HS2 right now, that is currently proposed at around 100 billion pounds. Now we can debate, is this a scalable type of network? And our answer is it absolutely is. Of course, on the one hand, we get the network effect from ever increasing different routes that we can connect. As you can imagine, if you have 4 points, the 5th point connects to all of the others. So you're really getting that exponential growth of how you can connect this. But all you need really on the ground is probably slightly outsized or slightly bigger vertiports, very similar to helicopter landing infrastructure. But this journey has not at all been easy at any given time. Building a startup is hard work. It's every day, it's new challenges. You don't have actually the reliance of 20 years of having done similar things. So we are every day having to move one step closer to our vision and actually being able to build the aircraft. It started about 5 years ago with a paper airplane with no processes and 4 wonderful people in a room that decided to go and fund this company. And of course, over the last 5 years, we've been extremely fortunate with having found incredibly strong investors that keep backing us. And more importantly, having gained the trust of 500 amazing individuals that make up the company. because without the team, it doesn't work. And we managed to bring amazing people like Yves Yemzi, who formerly was very involved on the A350 program, or Brian Phillipson, Dirk Gebser, many aviation heavyweights that have decided to put their name and their experience into work here. And we will continue this journey. We will continue to work very hard. We are, of course, now working very closely with a number of different aviation experts and industry companies in order to work on our supply chain, in order to continue gaining strengths and speed as a company. And I would like to invite everybody here as part of this community, as part of the aviation community, to come and visit us, to engage, maybe even to work for us or with us in some kind of way or form. We are working towards the 2025 goal. We have a lot to do, let's face it, but every day counts. And as a company, I'm strongly in believing that we can get there. And we genuinely hope in the next, hopefully live edition of Farnborough, we will be able to be there in person and to show you what is coming out from this manufacturing hall. So thank you very much for your attention, and I wish you a wonderful day.